Welcome. In this video, we are going to take a look at problem 38. It is from chapter 21 of College Physics 2E by OpenStax. We have this circuit and we need to find the currents. There are three currents, I1, I2, and I3. Okay, so we are going to need at least three equations. And we can look at junction A and apply the junction rule. Okay, the junction rule says the sum of the currents in is equal to the sum of the currents out. At A, we see that I3 is pointing in, and that I1 and I2 are pointing out. So I3 is equal to I1 plus I2. And there's our first equation. So we just look at which way the currents are pointing. If they're pointing in, that's a current that's in. If they're pointing out, that's a current that's out. Okay, now we can pick two loops. And it looks like we have three possibilities: the top half, the bottom half, and the whole way around. So let's just I picked the top half and the bottom half. All right, so I can mark the top half like this. So that's going to be one loop. And then, we'll pick the direction in a moment. And then the other loop can be the bottom half. Okay, so those are the two loops I'm going to use. Okay, in the top loop, I'm going to go around clockwise. And in the bottom loop, I'm going to go around counterclockwise. Okay, so let's mark up our resistors based on the currents that we have. And so we have I1 going like that and like that. The middle branch will be in both loops. We have I2 going like that and that. Okay. Where current enters is plus, where it leaves is minus. Current enters plus, it leaves is minus. Enters plus, it leaves its minus. Okay, same for the middle branch. We'll mark where it enters as plus and where it leaves as minus. And while we're at it, we might as well do the bottom loop, marking the resistors. Okay, so we've got I3 going like this. Okay, so where it enters is plus, leaves is minus, enters plus, leaves minus, and enters plus, and where it leaves is minus. Okay, so clockwise around the top loop, and we can actually just start putting in the numbers. So let's just say top loop. So we'll start at A, and we see the minus sign. So we're going to have minus I1 times R1. R1 is 5 ohms, so let's just call it 5. So we have minus 5 I1. Okay. Next is the EMF 1. We see the long end of the EMF last, so that's going to be plus 24 volts. We'll just call it 24. Next is the internal resistor. It is 0.10, and the last sign we see is minus, so minus 0.10 I1. Then we have our 5. Last sign we see is the minus, so we've got minus 20 I1. And then we keep going along the middle piece. The last sign we see as we traverse from right to left is going to be the plus sign. And the R2 is the 40 times I2. Okay. And then we have internal resistor R2. Last sign we see is the plus. So we've got plus. R2 is 0.5. And that is times I2. Then we have E2. We see the short end, so that's minus the 48 volts. We're back to A. That equals 0. Now we can combine the I terms, and we can combine the I2 terms, and we can combine the two voltages. So let's factor out an I1. Then we've got minus 5. Then we've got minus 0.10. Then we've got minus 20. Okay. Then we can factor out the I2. We've got 40. And we've got 0.5. That way we have fewer terms. We might as well combine them. And then we've got 24 minus 48. So that is going to be minus 24. All of that equals 0. And so if we add minus 20, minus 0.1, and minus 5, that gives us minus 25.10 times I1. Then 40 plus a half, we'll have 40.50 times I2. And then minus 24 equals 0. So that's another equation. So we've got, we'll call the one from the junction rule number 1. The one from the loop rule for the top loop, we'll call that equation 2. And now we'll do the other loop, the bottom loop. Okay. And we are going around counterclockwise, so starting at A and heading towards J. All right. So the last thing we see on resistor R3 is the plus sign. So we have plus, and it's 78 ohms, so we will call it 78 times I3. We go through the EMF. We see the short end, so we've got minus 6 volts, so we'll put minus 6. Internal resistor R3, we see the plus sign. That is 0.05, and that is times I3. Then we've got the long end of the E4, so we've got plus 36. Then we've got the plus end of internal resistor R4, so we've got plus 0.20 times I3. Now we traverse the middle, and we've got to watch our markings to make sure they're going to work. We are going around this counterclockwise, so the markings are fine. So the last sign we see on R2 is the plus. So we've got R2 is 40 times I2. And then internal resistor R2 is 0.5. The last thing we see is the plus. So 0.50 times I2. Then we see the short end of E2. So we've got minus 48. We're back to A. So all that is equal to 0. Okay. And so it's always good to double check, especially if you're traversing a branch more than once, just to make sure if you circle the signs like I do, just make sure you've got the right one circled for the second loop. Okay, we can do some combining again. And let's see. So let's factor out the I3. we've got a 78, we've got 0.05, and we've got 0.20. Okay, for I2, we've got 40 and 0.50. Okay, then we have -6 plus 36, so that gives us plus 30. But then we've got minus 48, so 48 minus 30, so we're going to have minus 18, and that's it. Okay, so we can combine, so we've got 78.25 I3, and then we've got 40.5 I2 minus 18 is 0. So here's our third equation. Okay. So what we can do is solve equation 2 for I1. So we will solve 2 for I1. So we've got minus 25.10 I1. And let's just start solving. So we know that's going to be minus 40.50 I2 plus 24. Okay. So I1, we're dividing by the minus sign, so let's just flip the sign. So we're going to have 40.50 over 25.10, because we've got a negative number divided by a negative number makes it positive. That's times I2. But now we've got a positive divided by a negative, so we have to subtract. So we've got 24 divided by 25.10. And I'm just going to leave the numbers like that, and I'll deal with them at the end. Now we will solve equation 3 for I3. Okay, so we've got 78.25 I3 is going to be equal to minus 40.50 I2. And then we're going to be adding that 18 to both sides. Double check it, make sure it looks good. Now we just need to divide by the 78.25. So we've got minus 40.50 over 78.25 I2 plus 18 over 78.25. Okay, so there's our equation for I3. Now we'll use the junction rule. So we will substitute into I3 is equal to I1 plus I2. So I3 is minus 40.50 over 78.25 I2 plus 18 over 78.25. Okay, that's it for I3. I1 is 40.50 over 25.10 I2 minus 24 over 25.10. That's it for I1. Then we have plus I2. I know it looks like a mess, but let's gather all the I2 terms on one side and then all the terms without I2 on the other side. So we can add the first term. So we've got 18 over 78.25. So we have 40.50 over 78.25 I2. We've got the 40.50 over 25.10 I2. We've got an I2, and we've got a minus 24 over 25.10. So let's add the 24 divided by 25.10 to the other side. So 18 over 78.25 plus 24 over 25.10. And let's factor out the I2. We've got 40.50 over 78.25 plus 40.50 over 25.10 plus 1. Okay, now we just need to divide by what's in the parentheses. So I2 is 18 over 78.25 plus 24 over 25.10. All of that's divided by the 40.50 over 78.25 plus 40.50 over 25.10 plus 1. Okay, I did that in the calculator, and I found that I2 rounds to 0.379 amps. So there's one of the currents. Okay, now we can go back and use these equations here to find I1 and I3. Okay, so I1, yep, we've got the 40.50 over 25.10 times I2 minus 24 over the 25.10. So I1 is 40.50 over 25.10 times 0.379 amps minus the 24 over the 25.10. I1 ends up being minus 0.345 amps. Okay, that is our I1. What that means is that in the circuit, I1 is going in the opposite direction. So instead of clockwise around the top part, it's going counterclockwise instead. But we will keep the minus sign because all our equations are set for the wrong direction. All right, and now we need to find I3. And we can do that right here. Okay, our I3, we had the minus 40.50 over 78.25 times I2, and then plus 18 over 78.25. I3 is minus 40.50 over 78.25 times 0.379 amps plus the 18 over 78.25. I3 works out to be 0.0339 amps, and we will call it 0.034 amps because there's an easier way to find I3, right? We know that I3, we can call this a check, is I1 plus I2. I1 was 0.379 amps plus I2, which is minus 0.345 amps. And this gives us the 0.034 amps. So we could have found it either way and checked with the opposite way. And so that is it. That's it for that problem. Woohoo. Okay, so we found our three currents. I hope you found this helpful. Let me know in the comments section if you have any questions or there are other problems you'd like me to see me solve. Thank you for watching. Please like and subscribe, and I'll see you in the next one.